There are many geometric figures that we can identify right-angled triangles in. It's important to be able to recognise these so that we can identify when we can use Pythagoras' theorem. A rectangle, it's a quadrilateral. All four angles are right angles. We can form a right-angled triangle by drawing a diagonal across the rectangle. A rhombus is a quadrilateral. All four sides are equal the same length. The diagonals bisect each other at right angles. A square is a rectangle and a rhombus in that all four corners are right angles and the diagonals bisect each other at right angles. An isosceles triangle has two sides the same length. The altitude, or if you draw a dotted line up the middle, this would form right angles with the base. An equilateral triangle has all sides of the same length. Again, the altitude of the triangle bisects the base at right angles. Bit of revision, Pythagoras' theorem says the square of the length of the hypotenuse, C, is equal to the sum of the square of the lengths of the other two sides, A and B. And you get A squared plus B squared equals C squared. Let's look at an example. Find the length of a diagonal of a rectangle of length 90 millimeters and width 4 centimeters. So the first step is to draw your diagram. Remember, a rectangle is a quadrilateral, all four angles are right angles. We form a right-angled triangle by drawing a diagonal across the rectangle. So we draw a diagram, we label it with the information provided. In this instance, they're giving us one length in millimeters. So the first step is to convert that to centimeters. So we divide 90 by 10, and we get 9 centimeters. Now we have enough information to use Pythagoras' theorem to find the length of the diagonal. So we write out our formula. In this example, the diagonal is the hypotenuse, so d squared equals 9 squared plus 4 squared. And then we get d squared equals 81 plus 16, d squared equals 97, and we square root both sides. And we know that d, in the exact form, is square root of 97 centimeters. Now we can finish that off, rounded to two decimal places, d equals 9.85 centimeters. So the solution is the diagonal is root 97 centimeters. So a square has a diagonals of length 100 millimeters. Find the sides of the square in centimeters. In this question, they're asking us for the solution in centimeters. The measurement is given to us in millimeters. So we'll draw our diagram first. And we know a square, all of the corners are right angles. Therefore, we can form right angled triangles with a diagonal. The first step again, because they're asking us for the answer in centimeters, is to convert our diagonal to centimeters. So we divide it by 10, and that gets 10 centimeters. Now this time we're not given any of the lengths of the sides except for the diagonal. So we have to label both sides that we know are the same length as S. So that we label S centimeters. Now we can solve. So we write S squared plus S squared equals 10 squared, which is our hypotenuse of our triangle. And we can collect like terms. We get 2s squared equals 100. Then we need to divide by 2 to get rid of the 2 in front of the s. So we get s squared equals 50. And we can square root both sides. We get s equals the square root of 50 centimeters. That's our exact answer. So our sides. And we can solve that to two decimal places. So the sides of the squares are square root of 50 centimeters. A rhombus has a diagonal of length 8 centimeters and 10 centimeters. Find the length of its sides. Remember, a rhombus is a quadrilateral with sides at equal length. Its diagonals bisect each other at right angles. So what we do first is we draw our diagram and label it. So we know that the diagonals are 8 centimeters and 10 centimeters. Therefore, half of the diagonals will be 4 centimeters and 5 centimeters respectively. In this case, we're trying to find the length of the side, so we label that x. And you've seen that I've drawn the right angled triangles in. Now we have enough information to find the length of the side. So we write 4 squared plus 5 squared equals x squared. So in this case, the length of the side is the hypotenuse of the triangles. So we get 16 squared. 16 plus 25 equals x squared. We get 41 equals x squared. Then we get x equals root 41. So again, x equals square root of 41 centimeters. Therefore, x equals 6.4 centimeters. So the sides are the square root of 41 centimeters. So an isosceles triangle has equal sides of length 10 meters. Now, an isosceles triangle has two sides which are the same length. Its third side is 4 meters long. Find the altitude of the triangle. So we know the altitude bisects the base at right angles, therefore we can draw a diagram like this. We're trying to find the altitude, which is the height of the triangle in this example. We're given the length of the base, and we know that the altitude bisects the base in the middle, so we know that one side will be 2 meters and the other side will also be 2 meters. Now we can use Pythagoras' theorem to find the length of the altitude. We write 2 squared plus a squared equals 10 squared. 4 plus a squared equals 100. And we take 4 away from both sides, and we get a squared equals 96. And we square root both sides, and we get a equals the square root of 96 meters. That's our exact answer. So therefore the altitude is the square root of 96 meters. Thanks everyone.